In my previous two videos, I've shown you how to graph the slope function from the original function. This time I want to do it the other way round. Firstly, I'm going to demonstrate it with the parabola. Now remember that in the last video, when we were working from the function to the slope function, there was a procedure. And first we needed to look at the maxima and minima. This time we're going to go the opposite way. The maxima and the minima became the zeros. So now we are looking at the zeros in this particular function. Where are the zeros? The zeros are here. They will indicate to us the minima and maxima of the original function. In other words, zeros will now become stationary points. Stationary points means a stationary point of inflection or a minimum or a maximum. To find now where those stationary points are going to be, what we'd like to do is to draw underneath over here the sign diagram of this slope function. So we're talking about the slope function here. And from that parabola diagram here, you can see that all the points here are negative and all the points here are positive, and on that side all the points here are negative. Why did I do this? Well, I needed to draw the sign diagram so that I can determine whether that point in here is actually a maxima or a minima, and this one whether it's maxima or a minima. And I can do that through that sign diagram. So a negative followed by a positive will mean that this is going to be a minima. And a positive followed by a negative is going to mean that this is going to be a maxima. Okay, so now I know that this point is going to be minimum and this point is going to be maximum. So I can now start drawing the original function up there. Now notice this is really important. I actually do not need to draw the axes. All I need to do is to draw where that minima and that maxima will be vertically. Now, that minima or that maxima could be absolutely anywhere. So this minima, I could draw it here, I could draw it here, I could draw it here. The maxima, I could draw it here, I could make it here, or I could make it here. And I could draw then my graph like this. I could draw it like this, or it could be like this, or it could be like this. On the other hand, it could be also like that. Anyway, I don't want to confuse you, but I will explain why. To understand why, let me just point out to you that if I had this function, which is 3x squared plus 2, and I had this function, which is 3x squared plus 102, or if I had this function, which is 3x squared minus 32, the derivatives of all of these functions would be the same. So it would be 6x. But the original functions are all set differently. So one of these functions may be, for instance, in any of these places. So as you can see, it's hard for me to determine from the slope function what the position of the maxima or the minima will be. Well, back to the original one, I will remove this. And for the sake of easier understanding, I will draw the x-axis and the y-axis. Now, the blue line indicates where the minima will be. So, as I said to you, where the minima is my choice. And I will pretend that it is here, okay? And for my maxima, I will decide that it is here. Well, the rest is really quite easy. I can join up these lines, the minima and the maxima, but I still want to show you one other part that we can determine. This maxima over here in the derivative function is going to indicate to me the non-stationary point of inflection. So if I extend that line here, this is where my point of inflection should be. So I can now draw here, and I can draw this and that. And as expected, I will get a cubic. So it's important, I said zeros will become stationary points. And the second part that you remember is that the maxima and minima will now become this non-stationary point of inflection. So this is an example here. And remember, we need to first of all identify the zeros, which are the in our slope function, and also the maxima and minima that will become. So I'm going to show you two other examples. Okay, first of all, this one, it's a cubic. What do we do? First of all, we identify the zeros. 1, 2, 3 zeros. Now we draw the sign diagram of that function and draw the lines where the zeros would be, points. Now we decide what is actually that this side here is positive, negative, positive, negative. We do this to find out whether D is going to be minima or maxima. Well, positive to negative means that this is going to be a maxima. Negative, positive, minima. And positive to negative is a maxima. Okay, also now note that these are going to be the points of stationary points of inflection. So we'll be able to draw them up to the graph, where I'll just start drawing the graph. All right, now that I've drawn my x and y axes and the green and yellow lines to show me where the inflection is and when the maxima and minima are, I can start drawing. The first maxima I can draw anywhere up here, and let's just say that I'm going to decide to draw it up here for the maxima. The second one is a minima. I can decide to draw it anywhere I like along that. I might do it here. And the last one, I'll draw it a little bit higher just for the sake of good looking graphs. Now, I know that the yellow will indicate where the stationary points of inflection are. By joining these maxima and minima and carefully, we get ourselves what we call this time a quartic graph. So I want to show you one more. This is also a cubic, but we want to identify the maxima and minima by looking at the zeros. So we identified the zeros here, and you note that it's only got 2 zeros, which sort of shows that it must have only 2 maxima or minima, but that's not the case. So I want to have a look at it clearly why. So the next step for us is to just draw the sign diagram here. And we'll need to connect these zeros to the sign diagram. So that's 1 0 here, and then the next one over here. And when we do that, we find that the values are negative on this side, positive on that side, and positive here. That tells us that there's a minimum in here, but how do we decipher the positive and the positive? Positive and a positive means that there is a positive, we've done this before, and a positive, which means that what we've got over in here is a stationary point of inflection. Yes, there is a maximum in here, so that's going to now indicate to us the non-stationary point of inflection. Yeah.
Are you taping?
Yes.
Because I've suddenly lost it, and I don't want to start mucking around with it in case I muck you up. So
Yeah.
I think I'm just gonna
Just watch the TV normally. I mean, it's not. It doesn't disturb me as long as it doesn't have it, loud.
Yeah, okay. But these are not connected to your thing, are they? At the moment?
At the moment, no.
No, because I've lost sound, and I didn't want to try to reconnect them in case it mucks you up. But it could also be that the battery's running flat, so I'll plug it in.
Okay. I'm nearly finishing this one, but I just want to get it done.
Yeah, and it's got to be done properly, yeah.
Yeah. What? It's you have to be in the mood to do that.
I know. You've got to be in the right frame of mind.
Because you have to think about it, how you're going to actually present this so that it is.
No, I fully understand that. It's like writing an essay.
Yeah.
Once you get into that mode, that's when you've got to do it.
Mm-hmm.